Hardware bonding is a fantastic technique of securing a threaded fixing into a deep section of timber. The method is so vast, it's well worth reading our technical publications on this very topic. What I'd like to do here is illustrate a very simple method of bonding a threaded fixing with an eye bolt into a thick piece of timber. If I show you the method in section, what we're looking at doing is drilling 2 holes into this thick timber, one that centralises the eye bolt and an enlarged hole here which gives us a good means of securing some filler in here which will spread the load almost like a washer for any tensile load that takes place on this eye bolt. Now I've got some good examples of a section through what this should look like. But you can see we've got our pilot hole which centres the fixing, and then you can see there's the broader diameter hole which allows us to get some filler in here. And you can also see, if we can get a really good close-up on this, how you've got some end grain here where the resin hardener mix has wicked in and further anchored our metal fixing. So how do we go about doing this? Well, firstly, we've got to make sure that we drill a hole deep enough. There's an excellent formula for this that is illustrated in our technical publication. So we drill a hole that's nice and deep. The depth of these holes should be 1/3 for the pilot hole and 2/3 for the actual area that you're hardware bonding. And the diameter of the drill should be the diameter of the fixing plus 6 millimetres. And then once we've done that, we can then drill a broader diameter hole to take our thickened epoxy mix. So we've got our prepared piece of wood. You can maybe see the 2 different diameter holes in here. So firstly, we're going to make sure that we use good personal protection. I'm wearing long sleeves to avoid skin contact. I'm going to put some gloves on again to avoid skin contact. And I'm going to wear some eye protection as well. All excellent health and safety stuff. Get myself a clean mixing pot, clean mixing stick, and I've got my resin and hardener here. I'm going to use the standard 205 hardener, and I'm just going to metre out 1 pump of resin and 1 pump of hardener because I want to make sure that I 2-step bond this. 2-step bonding is initially priming the surface with the resin hardener mix, allowing that to wick into the end grain fibres and then conducting my further process. 2-step bonding here is very, very important because I don't want any loss of filler into the end grain of either side of the hole. Very, very important. 1 pump of resin, 1 pump of hardener, and you can see that the pumps are already primed. I'm going to spend 2 minutes mixing this together so I get a nice homogeneous mix of both resin and hardener. So I've been mixing for 2 minutes. And now I can use a syringe to place my resin hardener mix in here. And I'm just going to leave that for a little while to soak into the end grain. So you can see quite clearly here the level of the resin hardener mix is reducing. That's a good indication that we're getting this wicking into the end grain fibres in the aperture that we've drilled here. Once you've left this for about 10 or 15 minutes, then it's possible to remove any excess resin. And now we've got the hole for our fixing suitably primed. That's the first step of our 2-step bonding process. Now I've returned to this after about 10 or 15 minutes and I'm ready to install my eye bolt. Now if I wanted to unthread this eye bolt, I could actually coat this with some release wax, something like Simonized car wax or kitchen oil, making sure that I've cleaned all of the threads out so that the shape of the thread is maintained. This will allow me to break this out and actually unthread it once I've secured this in with hardware bonding. But on this occasion, I'm going to place this in the pilot hole and screw it down till it bottoms out. So I'm now ready to make my filled mix, which is fantastic for the hardware bonding process. And for this, I'm going to use our 404 high density filler. This filler, when mixed with the resin and hardener, provides the maximum compressive strength of any of the other fillers that we have in our filler range. So for this, I'm just going to make up another pump of resin and another pump of hardener. I'm going to blend the two together, again mixing for 2 minutes. And I'm ready to add my filler. Now with any high density filler, 1 scoop of the filler together with 1 pump of resin and 1 pump of hardener will give you a good kind of nearly peanut butter type consistency. But I'm hoping here that I've got a consistency that I can pour. So I'm not exactly guessing. I'm using the scoop as a means of calibrating the amount of filler. And you'll see here that I've got a consistency that I can actually pour into my, my aperture here for my hardware bonding. Now this does require a degree of a steady hand and a little bit of skill to get this to pour in. I'm just going to do something else, just make it easier. I'm now going to fill the aperture with the high density filler mix. And I'm going to add my threaded fixing, working that into the hole. You can see how important it is to have the pilot hole in place because that centres the metal fixing perfectly. And I'll just clean this up. So that's our hardware bonding technique illustrated with our eye bolt fixed in place into a block of softwood. Not exactly an ideal wood to choose, but I'm sure that this illustrates this technique. It's a very, very clever technique. Now, of course, to illustrate this hardware bonding technique, I've just installed a metal fixing into a block of softwood. But what about if you very, very carefully coated the deck of a racing dinghy with maybe 3 or 4 coats of epoxy, and now you're ready to install all the deck hardware? Well, it would be a great mistake just simply to drill holes and put your metal fixing straight through the deck. It's important to use this type of technique to maintain the impervious nature of the epoxy coating. So, how good is this bond? Here we are with my hardware bond 24 hours later, and we're going to prove how powerful this bond is by testing it in a machine that will draw this eye bolt out and give us some very good figures and very good visual clues to how powerful this is. We can see here that we've installed our hardware bonded eye bolt in a special machine. We call this machine a tensiometer. And what this does is place a strong tensile load on this eye bolt, and it records the extension and the time. You can see here we're drawing this at an extension of about 1 millimetre every minute. As time goes by, you can see quite clearly the eye bolt is starting to extend. And this is the point where we are achieving failure of the eye bolt. You can see that the elongation on the stainless steel eye bolt has already gone beyond its safe working load. In fact, the figures that we're recording here are over 1,000 kilos. Here we are now with our block of wood removed from our scientific machine, and I think that more than anything, the visual clues as to the amount of significant load that this is capable of sustaining is really powerful here. Look how the wood has exploded as the plug has been pulled out. But for me, the most powerful visual clue as to how much load this takes is the elongation of the eye bolt. This is an original round eye bolt that this started out as. And 1,000 kilos or a tonne is the weight of a small car. For me, this test really does illustrate the power of this technique that we call hardware bonding.